Hey friends, welcome to the Adventures of Blink. I am of course Blink and I'm so glad you've joined me today. Make sure you like, subscribe, and click that notification bell so that we'll stay connected, and you can of course drop by the blog at any time for more content as well. Last week we introduced the idea of collisions. We made the paddle and the ball collide with each other. And that seems like it's working fine. But it's kind of boring. We don't have anything for the ball to do. We don't have any bricks. That's not going to be a very satisfying breakout clone. Building the bricks has a prerequisite though. Before we do that, we need to create a level. So let's build from this concept, from the ground up. All right, so the first thing we're going to do is open up this week's branch. So I'm going to do a git checkout. You can see that down here in the bottom left, I'm on main. So we're good to go there. I'm going to do a checkout -b, and we're going to do episode 6. We're over halfway through this season. It's hard to believe. It's just been going so quickly. All right, so now that we are in the episode 6 branch, we are ready to start building. Okay, so in order to build the level loader, we actually need to have a level to load. So the first thing we're going to do is come up here to our assets folder, and I have a folder already built out for levels. That may not be in yours already. It depends on what you copied from and how you uploaded, but the levels folder needs to exist under assets. And so what we're going to do is come in here and just do a level-1.txt. Okay, and this file is going to be a comma delimited list of numbers to represent the bricks in our level. So what we're going to do for starters is just build a block of blocks, if you will. So for instance, the top row of this blocks would have, I'm just going to use the number 1 to represent a regular brick at this point. The idea here is we can probably do other blocks in the future, but we'll use a 0 to represent an empty space if we want to have one. So I'm just going to do 1, 1, 3, 4, 5, 6, 7, 8, 9, 10 across. Okay, and just to keep things simple, we're going to do copy, paste, 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 paste. That's 5. Yeah, let's just go with 5 rows for now. So effectively, we've created a 5x10 block of bricks that are going to appear. And because there's a 1 in every space, that means there will be bricks adjacent to each other all the way across in every one of those spaces. So that's a good start. That's the first thing we're going to need. The next thing we're going to want to go build is in the core directory. So we're going to come over here to the core directory and create a new file. This file is going to be level.py. Now, the level class is what we're going to build in here. And the idea is that every level should be something that gets imported into an object. And that object is what we're going to use in the game window. The same way we did with the ball, the same way we did with the paddle, the level is represented in the same manner. So let's go ahead and build out our level loading system here. So we're going to start with from pathlib import path. This is so that we can actually get the stuff out of the file. We need the pathlib to be able to tell Python where the file is. The file is not in our root directory. It's not in a packaged folder that has an initpy in it. And so Python's not going to be able to find it unless we give it the ability to communicate with the file system in some way. So pathlib is what gives us the ability to build that path correctly. All right, then we're going to do from pygame, because each of these bricks is going to be represented as rectangles. So we're going to import rect. Okay, and it's important to note we're only pulling in the object from pygame that we absolutely need, which is rectangles. We're not actually pulling in the entire pygame library in the loading of level.py. So we're going to create a class level, and we'll go on ahead and define its constructor here. Now, the thing about the constructor is it's going to have to know some information about our environment before we can turn it loose. So we have to pass in the screen width and the screen height. And that's what we're going to do here. We're going to do screen underscore width and screen underscore height. And the other thing it's going to want to know is what level we're on. So we've only made one right now, but we are setting ourselves up for the ability to have a whole series of levels in this folder. So if you notice, I did level -1. Well, if I just keep putting numbers after that, I can actually make a succession of levels. So I can start with 1, and then I can work up to 4,793 or whatever it is that, I don't know. How high does Candy Crush go these days? I know there are people that are like on level 3 million or something, and they've been playing since I was born. But beside the point, we want the ability to be able to load a level just based on a number. So I'm going to come up here and I'm just going to add a level value as well. And that gives me all the things coming into the constructor that I need. Okay, so we're going to go ahead and remove the pass. And the first thing we're going to do is set a value for the current file. So current file represents the currently running file in the Python app. So at this point, it will actually represent level.py. Like that's the idea, is we loaded level.py and we've called the constructor, so we are currently running within level.py. So we need to get the path to that because that's going to help us know where to connect our file system things to. So we're going to start from the position of level.py and we're going to do path file and do a .resolve. And so that's going to return the path in a usable format for Python. The next thing we're going to do is actually set the project root. So we're going to do project root. Okay, and this is going to be current file dot parents. Oops, and I need these. There we go. All right. So what that does is it says, give me the parent of the parent. Since I have a 2 on there, it's going to go up 2 directories from where I am. So in the case of my level.py, that takes me core source. Okay, so now I'm at the level where source is. That's what the project root is. It's this folder, and if I shrink these down, you can actually see. It will tell me that I'm now 2 parents above my level, which puts me at this layer. Okay, and the cool part about that is I can now tell it where the levels directory is relative to project root. So self.levels directory equals self.project root, and we're going to do the assets folder, and then we're going to do the levels folder. Okay, so now I'm just traversing the path. Self.level file equals self.levels directory, and then I'm going to add in level-level done as an f string .text. Oops, that needs to be inside the quotes. There we go. All right, so now I've built level file as a path to the level file that I want to load. It's using this level as input, and it's building out the path and file name of my assets folder, levels, and it looks for level-1. So that's how we get there. All right. Now that I have that, the other things I need to capture, I'm just going to shorten these as I make them into a class method or a class variables. We're going to do a screen._width and do a self.height as screen_height. All right, now I've loaded up the level class with the information it needs to be successful. The next thing we're going to do is when we ask to load a level, we're going to make that a public method that somebody can call from the outside. So they'll say, hey, I need a new level created. And this is how we actually load the file. So we're going to do rectangles equals, and we're just going to make an empty array for the moment. Then we're going to do a data equals and do that. All right. So we're going to populate the data with the information from the file. And then we're going to translate that into rectangles. So width open self.level file, and we want to read it, and we're going to set the encoding as UTF-8, and then we'll do an as-f, just so we have a variable to use within this width. We'll do for line in f, row equals line dot strip dot split, and we're going to split it on commas. All right, so this says for each of the lines in the file, so it's going to grab one at a time, it's going to grab that, but it's going to know that there's the potential for white space, like a new line character at the end of it. So we're going to grab that, and then we're going to strip off the white space. So that takes care of any white space that would be on either end. In this case, there's only the one at the end, or at the very, like the right end of the row. And then it's going to split it into an array based on the position of commas. Okay, so now row becomes an array of each of these values. And instead of the commas, those just become the delimiter, and now I just have an array of ones, right? So then I'm going to take the data and I'm going to append this row to it. So now as I build this out, as I go through the file, I'm getting the data lined up in a two-dimensional array. All right, now the next thing we're going to do, we've now finished with the file. That's all it took to load the entire contents of the file into the data object. So next we're going to do a brick width. We're going to have to set the width of the brick. Now if you noticed, I was a little flexible on this. Like I could be flexible on this. I could take off a column of ones and make it 9 wide instead. What I'm going to do is adjust the brick width so that it always fills the space. That means that on small, easy levels, you could have really large bricks that are easy to hit. And then on really complicated levels, you can make them a lot wider, and then just based on the way you build the level file, you can up and down the difficulty level of your game. So brick width equals, we're going to do self.width divided by the length of the first row of data. So this first row is going to be used to determine. So if I put 9 elements in this list, then I'm going to have 9 bricks wide. If I have 15 elements in the list, then I'm going to have 15 wide. But this is going to determine the width of those bricks so that they can all fit on the screen at once. All right, and I'm going to do the same kind of thing with brick height, because I don't necessarily know how big the screen is. Remember that screen height and screen width are variables that are controlled from the config file. And so if somebody updates that and says, hey, I want this to be, 1920 by 900 or something like that, they have a weird custom monitor size or something, it's going to be controllable at that layer, and I need to adapt to it. So the brick height is going to be my height divided by 2 divided by 5. And that's the 5 rows. I suppose that there's a case to be made for using the length of the data object to control that, and maybe that's what I should actually do. I'm going to go on ahead and do it that way, and that way I have the ability to adjust if there are more or less rows in the file. Then I'm not necessarily limited to 5. When I first built this out, I kind of just predefined it as 5 was the number of rows that were going to be present in a level. But we could adjust that. We could make it fit differently, and so we want to be able to control that. That's how we define the width and height of the brick so that it fits within the model of the game we're playing. All right, now the next thing we have to do, we have this list of data that shows where the bricks should be. We need to start building an array of rectangles to match it. So for I row in enumerate data. All right, what we're doing here is going through the list of rows in the data, and you're used to seeing this perhaps as for row in data, right? That's the Pythonic way of saying it usually. But what if I wanted to be able to grab that index, because I'm going to need the index to tell where to put it in the next in the bricks object. So in order to grab the index alongside the row data, I'm going to use the enumerate, and then I'm going to capture both of those variables. Now, I'm going to do the same thing for columns. So I'm going to do for j column in enumerate, and I'm going to pull from the row that was set in the previous term. So now ij tells me what square I'm in at any given time. Now I'm going to do a new rectangle equals, let's build it, and we're going to make the rectangle, and we're going to set its height, and we're going to set its location. Oops, got a little overzealous there because I'm going to do brick width -2. Now, why did I do a -2 on this? Because I want to cut off a little bit on the edges just to make the bricks stand out from each other. Otherwise, I'm going to have what looks like a solid block when the bricks are adjacent to each other. So if I subtract by 2, I'm shrinking the edges and making just a tiny little border. It's effectively a 1-pixel border around the brick. And I'm going to do the same thing with the height that I did with the width there, and subtract 2 off of that so that I have a rectangle that's 1 pixel smaller than the size of the space it takes up. All right, then I'm going to do rex.append and put the new one in its space. All right, now I've built out all of the rectangles I need. That means the level is effectively loaded into an object. So I need to pass that object back, and that's what it means to load a level. Now we can load any level. We can even build multiple levels into our game. Let's incorporate this into our game window. All right, so the next thing we're going to do in our game window file, we're going to start up in the constructor for the game window. We've loaded all the other stuff. Let's make a space to load the bricks as well. So we're going to have to add in one new variable, and that's brick color. Well, there's 2 new variables because the other is the list of bricks, right? But we need the brick color, so we're going to get that out of the config. Let's see, we'll put that in the game section of the config. And then we'll do get brick _color. And if that doesn't appear, then we want to pass in, we'll just do a generic gray as the default. And now we've got a new brick color. That means that we got to take a little side quest here, and let's go find our config file. Here it is. And under game, we're going to add in, and you know what, I should be more disciplined on this. I'm going to do brick color up here. Now, let's see. We have a background that's bluish. We have a paddle color, which is white. We have a ball color. Where did we establish the ball color? We did not. Oh, we just left the default in. So the ball was red, I remember, last week. So in that case, I'm going to do, let's do green bricks. So we're going to do 0 for red and 255 for green, and 0 for blue. And that would be our new setting there. Now, just for giggles, we need to come back here and remember that we have a ball color. Let's see. Where did we use the ball color? Was that in the ball class, maybe? That was only a couple of weeks ago, but I've already forgotten where I put it. Let's go see. Do we control it in here? We do not. And this is why you should be more disciplined about the way you build out your variables, because now I can't remember where I set that. Let's see. I do know that the ball was red, so we can do 255, 0, 0, and there it is. Draw a circle. So here's where we drew it. So what we should probably do while we're in here is go on ahead and build out a default ball color variable. We'll do the same thing. We'll get the config, and you know what? Because this is all the same things, I can grab it from here. And we'll change this to default ball color, and it was 255, 0, 0. And now when I search for the 255, then I'm going to change this to be self.default ball color. That way I can affect that from the config later on if I need to. All right, so we've added in the things we needed. Went on my little side quest there. Now the last thing we need to do in the constructor is to actually set a variable to hold the bricks themselves. So we're going to come in here and we're going to do self.bricks, and we're going to set that to self.load level 1. All right, and you'll notice this doesn't work yet because load level does not exist within this method or within this class yet. So the next thing I have to do is actually define a load level method. Okay. Now the way that's going to work, it's going to take one variable, which is the level number. And let's see, it's going to be self.current_level equals the variable we passed in. Then we're going to do level equals level. And of course, this is not going to do autocompletes and things because we forgot to come up here and add. We're going to need from core.level import level. There we go. Now we can come back down here and open this up. Now we get an autocomplete that reminds us we have to do our imports. Okay, so we're going to pass in the level. We're going to pass in the screen width, and we're going to pass in the screen height. There we go. All right, now with that being done, the last thing we need to do is return level.load level. And so that will go out to our class. It will pull in the data and it will build the bricks. And so that's what gets passed back here to self.bricks. All right, so the big question that's now hanging over us, first of all, we have to go make sure we're going to fill the screen with those bricks. We're going to print them all out. But second of all, we want to know how we're going to handle collisions. And the answer is actually fairly straightforward. You have to check every brick every time to see if the ball collides with it. I'm sure you can find efficient ways to eliminate bricks from that list, but the method that I've chosen for this is more or less brute force. There should be plenty of time in our process to ensure that the the checks all get done. So we're not hurting for time. We're not taxing the system or relying on, deep GPU calculations or anything like that. So we should be okay. All right, what we're going to do is go down here to our run method, and in run, right after we did the part of colliding with the paddle, we're going to come right below that and open up another section kind of within this idea where we're going to do a new bricks array. And the reason we're going to do this is because it can be a really expensive proposition to remove a brick from an existing array. You're having to adjust the array constantly. It's actually faster, since we're going to touch every one of them anyway, to go on ahead and just rebuild the entire bricks array every time. So here's how we're going to make this work. We're going to do for brick in self.bricks. Okay. If the ball rectangle collides with the brick, then we're going to have to check the side of the collision. We want to know if it collided from the bottom or from the side or even from the top. Maybe it bounced its way around the board and hit it from the top. So somehow we have to be able to tell which way this occurred. That's going to help us know which way the bounce is going to happen, right? So we're going to do a variable to hold this, where we're going to do self.check collision side, and we'll use the ball rectangle, and we'll use the brick. And the way we're going to check this is, we'll go look at this in a second, so we'll come back to that idea. Let's just assume for the moment that we know which side we've now hit the ball into the brick from. So we'll actually write this out to the logger. This is a good debug message to have, to say brick hit on, and we'll dump our value in there so that we have an entry. Okay, now if the side is left or right, and I hope you see kind of the Pythonic way of dealing with this is to build an array of the things that it could be and look to see which one it is in there. I really like this syntax. It makes it easy to understand what we're shooting for. So if the side that I've detected, like I've done calculations and figured out, is in this array of potential options, then what I'm going to do is set the ball velocity to the negative of whatever it was. So if it hit on the left side or the right side, then I'm going to just reverse the x-coordinate velocity. Then I'm going to do the same thing for the verticals. So in top, bottom, ball dot velocity y times, oh, I noticed I left a typo there. There we go. All right, so now if I'm hitting on the top or bottom, I'm going to reverse the vertical velocity. So it'll just go whatever speed it was going, but in the opposite direction. And then if I hit on the left or right, it's going to do the same thing for the horizontal velocity. All right, now I'm going to else, because I didn't collide with this brick. So I'm going to do new bricks dot append brick. Okay, and the cool part here is I'm rebuilding that entire array every time. So I check and I go, did you collide? No, I put you in the pile for next time. You get to stay on the board. If I find one that did collide, then I actually address it right here on the spot. So I know to change the velocity, and that's the only other change. Then I'm not going to keep this brick because it's been destroyed. So I've done that. And now I'm in the for loop. So I really don't want to have to do another for loop to do the entire display. It would be better if I could just work while I'm in here. So I'm going to do my pygame.draw rectangle and do self.screen self.brick color, and I'm going to draw this brick. So now I've made one quick for loop to go through every brick. So if there are 100 bricks on the board, then I'm only going to have to do this one time for all 100 bricks. And by going through the loop in this manner, I ensure that the bricks are in the proper state for the next frame. All right, now there's some other stuff that we can get out of having the brick calculation done this way. Because if we come back with an empty array, we know we've won the game. Or we've beaten the level, I should say. So I'm going to add another thing down here at the bottom of run that says if not self.bricks. So if bricks is empty, we'll log a message that says completed level and then pass the current level. Okay, then we're going to do self.current level and add 1 because we started on level 1, and so the next one would logically be level 2. Then we're going to do, let's see, we should log that. We've updated current level, so we need to log its new value. Then we're going to do self.bricks equals self.load level self.current level. And then we're going to do, we have to reset the balls. So if there's the potential, because we have an array of balls in the game, there is the potential there that if we have more than one ball, we don't want to carry them all over. We want just a single ball to start every level. So we'll do self.init ball, and we will set that. All right. So now we should have all the levels in the game. We should have the ability to actually add multiple levels. So I think just for giggles, I'm going to come over here and we're going to make a copy of this and do a level -2 so we can see it in action. And what we're going to do is let's change every other brick to a 0. And this is actually a good case to have them be a little more narrow because it'll be uneven. And I don't know why I'm doing that. I should just do this. Oh, 2, 3, 4, 5. There we go. So now I've made a second level. All right. So we should be able to do a run in the game. Ooh, and we had a break because I forgot self.check collision side. We have to go back and add our method. I got ahead of myself there. Let's see here. All right, we'll come up here. I don't know where to put it. It can be pretty much any place within the class and it'll be fine. We'll just put it above load level. So we'll come up here and do define check collision side. And this is going to take self and then have a ball and a brick. And here's the way it's going to work. So first we're going to do some calculations. We're going to do absolute value of ball.right minus brick.left. And we're going to do DL, and this is absolute value of ball.left minus brick.right. Okay, so the idea we're shooting for here, I'll stop and explain it, and then I'll finish typing all the things. We want to know which overlap is the most likely, which overlap is the most likely direction that it came from. And the way we would tell this is to know that it's the smallest overlap. Because if you have a paddle and it's, this long, and you have a ball and it overlaps a little bit on the side, then that means it's probably on that side as opposed to being way over here. And so we're just going to use that nearest thing, the nearest neighbors between the sides to tell us which way the ball likely hit the paddle or the brick. So we're going to do for the bottom, and this is going to be ball.bottom minus brick.top. And then we're going to do dB, or dt, I'm sorry, absolute value of ball.top minus brick.bottom. All right. So then we're going to do a really quick operation to figure out which one is the smallest overlap. And we're going to do the minimum of all those items. Oh, and this was an equals that I was shooting for. Oops. Wow, my fingers are all... There we go. Okay. Now, if the min overlap equals dr, oh, and that's 2 equals, not 1. We're not assigning anything. We are checking it. So we're going to return right. If min overlap equals DL, return left. If min overlap equals DB, return bottom. If min overlap equals DT, return top. All right, now we should be okay to do this. Let's try this again. Okay. It's kind of working, but it's not doing what I expected. So we've still got some things to work out. We'll let the ball die out. Okay. All right, so this is a good opportunity for us to add logging to a level, to the level class, and see if we can determine what's happening. So we're going to come in here and do self.logger equals logger dot, I forget how to do this, logging dot get logger, and we're going to do class, and I believe we do name like that. Is that the way we did it? Yes. Okay. Now that means we also have to import logging. Or maybe I should just do that as a straight import, shouldn't I? Come up here and do import logging. Okay. So now that I've got that in here, I need to understand what got loaded. So we're going to do self.logger.debug. Oh, and I don't want this logging message above that. I want it below it. So we'll come right down here and we'll do, I need to make that an F string so that it will work. Okay. Now, let's go back to our app config and set the logging level to debug. Okay, so we're going to try to run this and see what we get. But I've run this a few times and I've had the log file out here, so I'm actually going to delete it and start over with a fresh one. This will make it easier for us to find the entries from this occurrence. All right, so we do a new game and we bounce off of there and we instantly died. All right, so that was a good sign. We can go ahead and quit. All right, now let's load up our log file and see what happened. So we got started. We loaded in the appropriate, see, that's got all ones and it's got all the ones we expected it to have. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wide, just like we thought. Okay, so we're loading in the right data. Let's go back and look at our level load. I think I see what I did wrong here. I'm doing J times brick height, and I should be doing J times brick width. And the reason we're doing that is because the array of rectangles doesn't actually directly correspond to the map. All it does is it builds out a list of rectangles that should be in those places. So it's using the position of the rectangles just to be like, it's immediately assigning a position to a rectangle rather than like trying to make it an array where you go, well, I'm going to do brick 5, 3. That won't actually work in the way that we're doing this. We're just loading a list of bricks and their positions are predetermined. So that was the mistake I made, which is why we had the bug. All right, now take a look at that. We can now see all of the bricks, but they are not disappearing like we expect. So something's up with that. That is going to be back in our game window. So let's go see. We're colliding with them successfully. It understands what's going on there, but for some reason, we are not addressing the disappearance of bricks like we should. And I think I can already see what I missed on this one too, because we build out a new bricks variable and then we never use it. So what we should be doing at the very end of the brick loop, like as soon as we're out of here, we're going to come right here and go self.bricks equals new bricks. And that's going to update the screen so that on the next frame, things are in the proper order. Like we immediately get to see the changes. So let's try this. There we go. Check it out. We now have a working game and it bounces off of everything and it might bounce off multiple pieces in the same way. And so now that's how we get our game to work. Pretty cool, huh? All right. Now the other thing that we can do, and I'm going to go back and make a quick adjustment to this so that you can see it, because this is really a sweet way to test this out. If I just made the list look like this, just one column of bricks, that means that the width is going to be calculated at 100% of the width of the screen. And this makes it very fast for us to test because now I've only got 5 bricks to clear. So all I have to do is this, and I can check the next level load. So this should, upon completion, load the next level. And it does. Isn't that amazing? And so then I position and I get ready and bang, now I can start level 2. Although level 2 did not load the way I expected it to. And I think I know why that is. Yeah. So let's go take a look at that. The problem we have in level 2 is that we never made the level loader respect the type of bricks that it loads. And so if I go into level.py, let's see, when I am creating new bricks down here, I should be checking the value of column. So if col equals 1, then do this. Oh, and that was not what I expected. What I wanted was to do this over here. Column selection mode is a little less than fun here. I need to change my selection mode. There we go. So now I can do a tab and it'll go over. All right. So now it should only load the ones, not the zeros. The zeros should be left blank. So, oops. Okay, after a little bit of movie magic here, I had to do some digging to figure this one out. And it, as usual, when you have a weird bug like this, the answer always makes you feel stupid. So here's what I did wrong. Right here, where I'm testing whether the type of, like the entry in the bricks list is supposed to be a brick or an empty space, I just did it equals 1. But the problem is, this is a string coming in from data. And so I have to do it this way in order to make it work. And so that is why it was just automatically closing, because it never found a brick. And now I'm really bad at breakout. So I'm going to try to finish this off and hopefully we'll see. There we go. Level 2 now successfully loads immediately following level 1. And so just like that, you have the ability to play the game. And that, my friends, is how you get Breakout to work. All right, that wraps up today's adventure. Next week, we're going to start making a way for us to win the game. Remember to like, subscribe, click the notification bell, and of course, stop by the blog. I'll see you next time.